we're going to discuss about three platforms and languages. They just happen to be. Node is not a language, but you get the point. Python, Java, and Node. Okay, who am I? I'm mostly a Java developer. Then I'm a JavaScript developer, and then I do Python. All our applications are written with Spring and all the good GEE technologies, which someone says explicitly he hates. Then we build a lot of the UI. We have actually some very rich clients written in JavaScript, and I even compiled a tiny statistic of the JavaScripts which eventually I have to maintain. So we're having, I don't know, in the bazillion of lines of code and words and stuff like that. So because we also have fixes on top of Editor, jQuery. In IE8, for example, we have support for IE8, stuff like that. Doesn't matter. But the idea is I know JavaScript a lot, even with differences in browsers. And in Python, nonetheless, it was our favorite scripting language, especially for testers, because it's a unifying language. It's an easy language. It's actually, you can read it, unlike some other programming languages, which if you don't know the syntax, you look into it and you have no idea what's going on. Ruby is one example. Like, you look into it, if you don't know the language, you're screwed. Just go read the sources, or I don't know, anagrams or something. It's the same thing. So this is why we're having these three languages, and we use them extensively. But in the recent days, my plan is to move the Python part into JavaScript, and I will explain why in the next slides. Okay, what we're going to be discussing today is we're going to be discussing about the platform, that is the execution platform. We're going to be discussing about modules, on how we structure parts of the application, basically. When we build an application, we build it from smaller parts, right, which are modules. Preferably, we actually fetch some of them from some other people. And we're going to talk about the programming languages, because all these three, they work together. We can't have them in isolation. I can't, okay, I'm going to write now, I don't know, Ruby, and I'm going to run it on Node. You know. Okay, so let's start with the platform. Platforms, I categorize them in three types. Platforms that run native code, which is basically stuff you compiled. Platforms that run bytecode, which is, I hope everyone knows what bytecode is. And platforms that interpret or execute language. So, for example, in the bytecode, it's Java. Java executes bytecode, and since from Java 1.4, they didn't change the instruction set. They've added one instruction in Java 7. What it means is all the libraries which were written from Java 1.4, they still run with the same instructions in the latest Java 8. And this is a pretty good guarantee. I feel pretty good if I know my application is still going to run on Java 10, for example, without having to change it. On the other hand, Python and JavaScript, they are driven by the language. So the platform is going to execute the language in order to figure out what exactly is going to be executed. Now here's where things get interesting. Python between 2.7 and 3.4, which are the latest versions, actually between I think it was 6 when 3 was out, they are not compatible between them. What it means is the code which is written in 3.4, it's very likely not going to run, or actually 2.7, it's not going to run in 3.4. And you have to be careful when you write it. For example, print. Print became a function in 3.0, and it used to be a keyword. What it means is you have to put parentheses around it. But all the code before, which didn't have parentheses, and it's a tiny thing, doesn't run now. What happens if you have a library which is written in 2.7? Well, good luck, you have to find all the parentheses. And you have to put them yourself. I think there's also some minor changes in the classes and stuff like that. But something interesting happened. Oops, JavaScript remained only one version. If you think about it. Can I take a JavaScript application or a JavaScript class and run it in Node? I can ask these guys when they did the upgrade from Node 0.10 to 0.12, did they had issues from the language? Maybe they had some issues from some random library, but it wasn't the language. Why? The reason is we can thank IE. This is a joke now, but this fragmentation, what it means is everyone has to be backwards compatible. These are from October, November last year, these statistics. For example, we still have to support IE8, right? Because a bunch of corporate customers of ours, they really cannot update their browser. And I can't go there and say, hey, you know what? You have to update your browser because we lose them as a client. That's it. This is the end of the story. They'll find someone else. Okay? So what happened was, somehow, magically, JavaScript remained supported across the browsers, even in upgrades. And upgrades in JavaScript, they're always backwards compatible. This doesn't happen in all the other dynamic languages. Ruby, it's another example where they broke compatibility. What happens? Libraries fork. You can't update as easily. It's the same story with native stuff, which we're going to go later. And what happened was, JavaScript became the assembly of the web. Because what you can do now is you can write in whatever language, you compile for JavaScript, and you know you're guaranteed that that JavaScript is going to run. You cannot guarantee that with Python. Because again, if I compile something in Python, well, if you have Python 3 or 4, there's a big difference now for me. Even the libraries, they changed a bit. So I can't run them anymore. The next topic we're going to talk about is modules. Now, the thing is like this. When we build applications, our applications, they tend to scale. So you start small. You start like, I don't know, I have 5 classes. I have just a tiny thing which opens my dialog up. Okay? Now, you realize this dialog is actually pretty dumb, so you want to have some other components into it. So you add some, I don't know, jQuery, UI, or whatever widgets you pick. In the Node world would be, I don't know, you add some library of some sort, okay, which you need. You need to actually implement your functionality. You don't want to do it from scratch. You want to structure your code. So the code starts growing. Now, there are applications which allow you to work with modules. In the Python world, they are called pip and easy install. In Python, until 3.4, they didn't have embedded, so part of the installation package, any package manager, which was kind of weird, to say the least. So imagine this. You install Python for the first time. You want to use Selenium, the library, right, to write a test which runs with Selenium. You can't download it. The first thing you have to do is to install a package manager which will actually convince Python to download the package. That's a kind of a chicken and egg problem. And also, to install pip, you would need to have easy install first. Because easy install, pip was a package in easy install. I didn't make that stuff up. I don't know, this is how they did it. Like, I have no idea what was in their head. Now they're at node level. In the Java world, there is the Maven. And Maven, it's really cool. Maven, it's fantastically good. You can actually say what packages use what packages. You can do analysis on these packages. You can actually ask, okay, if I would build this application, what would I get and how would you resolve them? Because you can also have some dependency conflicts and stuff like that. And Maven, it's really good at working with this kind of scenarios. And obviously you have an NPM. And the cool part about NPM is the only package manager which comes with the platform. Java doesn't come with Maven either. You have to install it. And Maven itself, it's not easy. You have these packages which you would write, they would be in an XML file. And the format, without tooling, I wish you good luck. Like, honestly, like, well, you know, you tried at least. This is, you know, your merit. And the other thing which I want to discuss is the resolution of modules. Resolution is what happens if you want to use something from a module. Okay? So, for example, let's say the classic example of Selenium. I want to use Selenium. Where do I fetch it from? Okay, and what happens if Selenium, for example, needs some logging library? Okay, might happen, makes sense, right? What library, how this library is going to come into the executed code of my application? Now, there are 2 approaches to this. One of them is loading modules, which is what NPM or OSGI in the Java world does. What it means is when you load a class, it's part of the module. I'm going to show you a diagram afterwards how this goes down. The other approach is you have a list of every single package you depend on, and you start searching in every single package. So let's go with the first one. If I write an application, and this application needs 2 libraries, library A and library B, which library B happens to need library C. What will happen with a module resolution, so for example, I want to load library B wherever, it will look the same. Okay, so when I would load stuff for the application, it will be visible only inside the application. And the stuff for library B, it wouldn't be visible in library A. I couldn't make it visible even if I would want to. If library A would need library B, they would have a different instance of library B. It wouldn't be the same instance. Okay? Are you with me now? What this does in turn is it guarantees I don't get breaking changes. Because look at this beautiful scenario. If I have the loader, right, this is that approach. I would go just, if I need a class A, which is library A, it will search it first in the application all the time. It's not in the application, okay, we go to library A, okay, we go to library B, so on and so forth. If I add a conflicting dependency, like in here, this is where things get interesting. If I use module resolution, since I have library A and library C, both depending on an incompatible version of library D, so I can't use it, the API changed. I can't use library D version 1 for library A. Library A is going to break. What happens with the module resolution, it just works. Okay, fine. Library C is going to have the version 1 loaded in its own part. Library A is going to have version 2 loaded in its own part. And unlike this version, and everything is going to work in here, but in here, stuff is going to fall apart. Because what happens is, if I need class D, it depends on the order in which my class loader, or in the Python world, it's called syspath. It depends in what order the module appear. Okay? If the module version 1 appears first, we load the class from that module. Okay? But that means, if we look back in here, that library A is going to fail because it needs the second version of the class. If I switch them, the other library is going to fail. There is no win situation in here. What we do in Java sometimes, we have, thank God, static analysis, and we can actually move classes in other packages, but we have to manipulate the jar files. So we go and move them manually in other jar files. So we will have, there are tools which can actually do that for us. But we still have to do this manually. We'll have the errors at runtime, and stuff falls apart. If we deploy applications on servlet containers, if it's stuff like WebLogic, stuff falls apart all the time in there. And it's always tough. And OSGI, which is the other solution which we do loading like this, it's not easy to set up. It's really, really tricky. You have to add a lot of metadata into the meta-inf. You have to specify not only what jars you define, but also what packages you export, what classes you need, stuff like that. And it's really, really easily, if you don't have very good tooling support, you can't do it. As in, I cannot do it. Maybe there are other people out there, no? Okay, so in here you don't win. So now we go to the last part, which is the languages. And as I said, there are two kinds of platforms. Platforms which execute bytecode and platforms which execute the programming language. As I said, there were the other ones, the native ones, but let's exclude them. What happens with Python? This is what Python supports. Python 2.7, Python 3.4, and depends on what version you picked. It doesn't support them. You don't have backwards compatibility. They wouldn't have issues if that would be the case. So depending on what Python version you pick, kind of Python, the platform comes with Python, the language, and that's it. This is the end of the story. You can't really use anything else. So this is why, unless you're very happy with Python, I'm very curious, like unless as in the language, and like you really love Python. No, Python. I don't understand why you would pick Python, honestly. I can even give you another example where Python, like it's really, and I say that, I shouldn't say that because I know here there are people who use Python. But still, where Python is really horrible. The thing is you need stuff like graphics processing, right? So let's say you want to render some graphs, okay? Now Python, because it's interpreted, and wherever runtime you'll find it sucks, it's very slow, okay? It doesn't have bit operations. That's it, end of the game. Now you can't make fast operations with images if you don't have bit operations. What everyone does, native binding to some library, right? Yes, you will have a native binding to a library, and this is the interesting feature now, because in their pip, in their install manager, they won't be compiled to your system. No, you have to have them pre-compiled somehow, from somewhere. And what happens is you can find the website actually, which is pretty cool, where you find a bunch of packages with installers made by some professor in some university, so you can get the graphics library rendering. So what it means in reality is if I want to install on 3 machines Python, and I have to use GD, which is the graphic library to render stuff I was mentioning now, I'm going to install Python with the installer in the first machine, second machine, third machine, and then go install GD on the first machine, second machine, third machine, and then, whatever other packages I would actually fetch from pip, because pip cannot bring me binary dependencies. Good job, Python. I'm not going to use it. Anyway, so the other thing is if you run bytecode, suddenly stuff is completely different. The thing is, since you have to compile to bytecode, or you can interpret it, you can actually run multiple things. So for example, Java, Groovy, Scala, Haskell, they all compile to bytecode. Now you also have Jython, which is actually an interpreter, but only for 2.7, because again, language, you're tied to the language. You can never go out of the language. JRuby and JavaScript. In JavaScript, amazingly enough, Mozilla does a great job. They actually support even the latest ES 5 or 6 even. They really support it straight from Java. So I can actually execute JavaScript in my Java runtime, accessing my Java classes. And we do that in our production server, for example. Again, so, but from Java, from the Java environment, because of the security and blah, 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 we have a lot of cool stuff. Now, in Node, we also have the same story, because again, what I was saying before, no? The JavaScript, it's the assembly of the web right now. You know, you can get all these languages like JavaScript, CoffeeScript, or TypeScript and compile to JavaScript. But JavaScript, it's literally not the JavaScript you would write, except for TypeScript. TypeScript is pretty close. But the other ones, it's not what you would write. It looks like something else. And what happens now is ASM.js is out, and also WebAssembly comes out. And how this one is going to change the things is you will get really, really good performance. WebAssembly, it's literally bytecode for the browser. It's really, really bytecode. So they're going to implement bytecode in the browser. And since I have a feeling this is going to be part of the JavaScript engine, I have a strong feeling it's going to get part of Node. You know, so I have a strong feeling in like 2 years, we're going to have WebAssembly part of Node. And what it means is we can actually compile objects, you know, like C objects, straight to WebAssembly. Not like ASM.js thing, LLVM things. I don't know. For me, this toolchain is really complicated. This is why I don't like it, and I make it like, it's like if I have to go to LLVM and blah, blah. I've seen also some demos. I wasn't sold. So let's do a demo now where I'm going to implement, the thing which I want to demo now is this. If I'm implementing a module, right, and I'm working on my application, and I also develop library B, you know, but then suddenly I find a bug in library B, what do I do? Okay, this is going to be the demo. If you programmed in Node before, this demo is going to suck. It's going to be like really boring stuff. You already know it. If you didn't program, what I want to show you now is the capability of Node to work with modules which are loaded. This is one of the most powerful loading module approaches in the industry, and I'm not kidding this. C# guys, they can confirm it. DLL, hey, how do you do it? How do you do it with assemblies? It's the same story everywhere. It's the same story in Python. It's the same story in Java world. And there isn't a clean solution. There isn't. You have, again, unless you write a bunch of metadata.
But there's also drawbacks.
I didn't say that there are no drawbacks. This is why everything you export is functions. Why you don't export objects or classes? Because they are different classes. If I would export here class C and I want library A to see it, no, I can't. Think about it. If library A needs C, library B needs C, they're going to get different instances. It's the same story with D. Assume it's the same version. I get a D instance created by library C, okay, in my application. And then I pass it to library A. Library A, this is instance of D. No. Because they check it against the class loaded from there.
Yeah, shared dependency.
You can do that? Yeah, there you go, problem solved. Your face. I didn't know that.
Application. But if they are not somewhere compatible, you still got two separate versions.
Yeah, in my opinion, I wouldn't do it anyway, but that's the different story. Especially for external dependencies where I cannot guarantee my dependency. But again, let's do the demo. I'm going to close the mic now, I'm sorry. I hope I can close it. Okay, so in here, I already have an existing package, which is ViennaJS took existing, and I'm going to create a new one. And I'm going to edit the package JSON. Okay, and I'm going to have Vienna. Now, what I'm going to do is I'm going to add a dependency to the previous package which already exists, which is ViennaJS exist. So npm install save ViennaJS exist. Now this is actually going to connect to the internet. You all know Node and npm, and it's going to fetch. I already published this version, this beautiful package, into npm. Okay, and now let's write. What do I need to write? Lib Vienna new package. Okay, so let's make a folder. And let's give the Vienna new package JS. Okay. In here, we're going to have the old package. Required. ViennaJS. And in it I have only two methods, which is perfect red and perfect green. I can actually do it. Yeah, perfect red and perfect green. Yeah, so what I'm going to do is I'm just going to log them. So old package. Red. And I've introduced on purpose a bug in perfect red. Okay, so now we can actually execute it. So let's try it out. The red is blue, so unless you're colorblind, the first red should be red. It's not red. And this other one should be green, unless I want to mess up with your head. So, okay, so this one, the first one should be red, which is the blue one, and now the other one is green. But we already implemented this module ourselves, right? Even if we published it, it's still our module. So what we're going to do is we're going to link it. And what happens is, unless you don't know Node, what happens right now is I have a link in my Node modules for the other module. So whenever I change the code, I actually change the other module independently. Still with me, everyone? Okay. Perfect.
Say it again.
Okay. So what happens right now when you link, you create a link to your other folder. So whenever I would change files in the other folder, which is also my project, I work on the live system, but the npm install module is not the one from the repository. It's the one which I have locally on my disk. Okay? Okay. So I can actually do it in the other folder, so you can here. Existing. Okay, and we see, okay, our red is actually red, so it's good. That was the bug. Okay, so we make it red, and now I just execute again. I don't have to do anything else. I changed the module which I'm depending on, but I just need to execute it, and it's changed. Okay, so actually it's the bug. So what we can do now? Let's put the bug fix in. And we'll put up the update for the existing package. Yay, we have it. And we can also publish this one. And that's it. And this alone, it's so powerful, I don't have words to describe it. And the reason is, what this allows me to do is I can create scripts, I can create servers, I can create full applications, and use Node as a deployment platform, which guarantees me the modules are going to be right. So the guy who actually fetches my application, it's going to work for him, and I don't have to care about his runtime.
Do you understand all this? This is so cool because there is no other platform which can do that. Not Java. Because Java can guarantee you some stuff except if you go into the module help. Python can guarantee you some stuff unless you want native bindings. There is no way out for me. I can't go in. There is nothing I can possibly do where I can, unless some triple hack, I don't know, fetch my DLLs or like Java does, where you put DLLs in the jar file. And the jar file then kind of, start loading your DLLs and blah. But this is horrible. This is, even I know it's horrible. And I'm actually a big fan of Java. So, this being said, the languages and whatnot, we had seen the demo. These are the conclusions, especially for Roland, who said, what's going to be my conclusion? It's a bit more. The thing is, the conclusions are these. The platform itself, it's awesome. It has module isolation, okay? What it means is every single module, it's being loaded in its own part, so what it means, it won't interfere with the other modules. Performance, it's here to stay. We have ASM.js and WebAssembly coming out. We also have platform independence. Most of the stuff is implemented in JavaScript. I strongly recommend if you see a module which is natively binded, don't use it. If you can, of course. I saw socket.io. Turns out it's compiled. Well, yeah. I wouldn't use anything else for that one, for example. Modules are super simple to write. I actually have a macro in my Vim, if you noted, where I just type in package and I get a package. And I just type in wherever I want, like in there. I also am a big grunt user, so I don't know. I also have for grunt, stuff like that. And it's the same story. If I want to start a project, I can do it immediately. And on the long run, which is for me important, I know not everyone, type safety is also very important and I need it. Our application, as I said, it's in the hundreds of classes. I can't refactor it now. I'm being very honest. It's like it's so huge. And I'm using type annotations. I am one of those guys who actually write that every single class, add type, wherever, whatever method parameters, I put the types in. And the idea can do so much, but if you don't have actual type inference, like real type inference, you can't go with heuristics and move classes around. And yeah, also language constellations, which again, as I said, Python doesn't have. Questions?
I'm not aware if I just missed it or if you didn't mention it in your talk, but you can actually use something very powerful in Node, which is called native models. So you don't need this ASM.js mumbo jumbo.
The point I was trying to make is actually you should avoid them. Yeah, but go on.
Yes. Well, you can't avoid them completely. Like if you need some capability of the operating system, you need to have some sort of way to communicate with the operating system.
That's
and you
true.
can pretty much only do this with native model.
Yes.
And actually C++ is a platform-independent language. So if you are running Node on a platform where you have a C++ compiler, you can have platform-independent, very fast code that will run on whatever platform you're deploying your application with. And if you're using it in that manner, then I recommend it.
This is a loaded statement, and it's, I think, yes and no. The thing is like this. Let's say this. Okay, I want to make my native library, right? Sol has this, I don't know your name, I know you Sol. And, no, but really my daughter is like 5. The thing is like this. If you want to build an application, let's say you want to use some, I don't know what DLL. Microsoft has this awesome new feature in Windows 10, which you can start IE, OpenGL, enhanced mode in mobile and blah. And you implement this one in the native module. What it means is your module is tied by that platform. And the big problem that I have is in general, as I said, if you tie your modules to a platform, you're not platform independent anymore. And what it also, at least in my language, means is kind of your platform execution sucks. Because this is what happens with Java. Most of it, it's not part of DLLs. You won't, if we have to use DLLs, it's usually because some vendor had a C# component and they had no other way to give it to us. So, and they give us a DLL, and we have some wrapper into it, and then Bogdan swears to days for why the heck did you do that? Because I can't run it because you cannot find the DLL, random exception stuff. Blah. And this is my point. If it's just an algorithm, I don't see the benefit if I have, for example, ASM.js, which can compile it to me, or C++ one.
Twice the speed.
I can live without it. If I get platform independence. I'm already using Node for crying out loud.
the problem with the native modules is not, of course C++ code is platform independent. So you can compile it on all the different
Depends on
platforms.
what it does. It's not true.
Yeah, the problem is the C++ node bindings, because the V8 API is not stable.
We use nan.js and your problem is solved.
Yeah, but non.js, the non-module.
Can you hear the question? We can take it offline. This is okay.
So, I mean, I just went to the native thing because, for example, Node.js is just a wrapper for libsys, which is written in C. And it's also like native code because it's so much faster than compiling SAS code is
Well, for example,
expensive. But I mean, the goal of this library is like they will only use like platform independent C code.
well, the thing is, I don't know, SAS is another example. I don't actually I also use SAS. In our project we use SAS, actually Compass, but we use the Ruby.
Yeah,
And the reason
but
for that is,
it's slow.
no, it's not that slow.
Yeah, it's really slow compared to Node.js.
If you say it's so, no, then I cannot say it's not so, and you know, it's not slow. You know, I can say something like this: C sucks, right? And then someone comes, oh no, C doesn't suck. No, but it does suck. It's like horrible. It has like pointers and whatnot, right? And it's very hard to say, well, yeah, but you can embed it. I mean, come on, right? It doesn't suck. It depends on what you're using and stuff like that. And if you say it's slow, right? We're using it. It's not low.
Yeah, it depends how you're using it. For example, if you do like live load or processing stuff, so when
We
you
do that, yes, and it
yeah.
works well.
But I mean, it's for large SAS code bases. Like
Works well.
you
And we have
can at
really
least double the speed of the SAS compilation by 2 by using no SAS. In
Okay.
my experience.
So I get 200 milliseconds more.
Yeah.
Okay. I don't care. This is the stuff. Yes.
Enterprise development.
No, but even, for example, I wrote my own I call it fast live reload. The thing is, I wrote my own live reload tool. The thing is, for a lot of the watcher things you would see out there, you don't have a legit answer. If there is no gulp thing to do my SAS compilation in time, unless I go with T-bindings, then even that one, I bet you is not fast. And the reason is like this. If I have a huge code base, right, which you just mentioned, and I change 10 lines of code, right, what happens? Do you recompile the whole thing?
No.
You kind of have to. You kind of have to, because otherwise you have to be integrated so deep with the actual language of the thing, so you have to know what to trigger, because if I change a file, well, what if this file is referenced in RFI files? It's not just the file which matters. It's all these dependencies which you cannot tell. Your tools, your gulp, wherever build system, you can be the geniuses of geniuses, cannot tell it unless you re-implement the whole thing. So what happens is, this is why I actually use the watchers, the native watchers. This is why I use the Ruby one. Because it knows, and it loads everything. And yes, if I change one file, it's super fast. Yes, probably faster than the C one. Well, I don't know. Let's not go on just those signals. But it's super fast. The same story goes with TypeScript. My live reload, for example, which I'm using, it doesn't attempt to watch files like TypeScript. Because it's going to fail. It's always going to be worse than actual TypeScript watching the files. It's the same story which goes with Compass. If I would start monitoring SAS files and I see, okay, if SAS files changed, let's rerun the build process. I will have to somehow integrate so deep with the SAS build process to tell it only those 2 files changed it. And if it's not already running, which should be running because I need to have everything else cached, right? All the syntax tree for everything, I'm definitely going to be slower. Definitely. And I can bet that. We can benchmark it. This is, I'm willing to go down with this.
I mean, I haven't done really a lot of benchmarks, but there have been a lot of benchmarks on the internet, and it's always
the
saying
benchmark
that.
is always like this. And I can bet you it's like this. We run grunt. And grunt watches everything, and we run the task. And then we run stuff like gulp or wherever, and it's much faster because it loads. But the benefit,
Yeah, but if you're using Ruby SAS and like compiling single modules or something like that, you.
but I watch it. I compile it once per build, and then I don't care if it's 20 seconds. And if I watch it, it's the 20 seconds the initial compilation, and afterwards it's literally milliseconds. You cannot be much faster than the SAS itself compiling its own things.
Yeah, but I mean, libsas is just. I mean, they just re-implemented SAS in C.
Yes,
It
but
knows
yes.
the same stuff.
Okay,
So,
get
so
20
how
minutes.
come you suddenly care about speed?
No, but I said it
I thought
in
you
a
used
context.
Java.
before you said like, I don't care if it takes twice as much time. So now you do care.
No. The point he's trying to sell is like this. The point is he's trying to say, with native bindings, you get so much better speed. You know, it's like a visible difference, 20 times faster. You know, I get half a second, you get 10 seconds. This is the point he's trying to sell. And I'm saying this is not true. Unless you have, like, I don't know, if your build system sucks, then yes, it's true. This is the difference. I don't care, I just said that. If Compass SAS goes 500 milliseconds slower, I don't care. But the benchmark, the actual visible speed, you won't see it in the native part. This is my 2 cents. Sorry. Yeah.
The distinction between Java, Python, and JavaScript as bytecode language and interpreted language is pointless because they are all interpreted. You made the difference only because you
It's not true actually, but go
yes,
on.
it is. Yes, because by default JavaScript only emits to the intermediate representation. Let's not call it bytecode. Let's just call it intermediate.
Okay.
Only to the memory and not to the file. Python occasionally emits IC files.
All the time, if it's Python all the time.
Right. But technically, it's the same. The distinction is only native code combining to the instruction set of the CPU and some intermediate code, bytecode, whatever, which is going to be interpreted, perhaps JIT. But there's no technical distinction in the.
Well, actually it is. The thing is like this. If you have Python, for example, the thing is like this. If I have a module written in a language, right, and I need the stuff to be interpreted, or even if I would write it to machine code, but I depend on the specific language format. You know, this is the point I was trying to make in there. The thing is, with Java in particular, I don't know where you get your information from, but in Java at least, this is where I can promise you. Hotspot already does inlining in native code for your Java methods. If it figures out it can do that, and it's more performant. It already does that. And this is Davi, for example, if you have Android, you'll see it like, if you do updates, it compiles a bunch of stuff. This is actually writing you the native code. There is no more interpretation anymore. There's a difference when we're talking about we're interpreting things. Like we see this instruction, where should we go next? If there, go there, if else, no. It's a difference when we execute code and when we interpret code. This is one difference. And the thing is with bytecode, what it offers you is it's taking the language out of the picture. There is no more Java after bytecode. There's bytecode, that's it. If I can generate it wherever.
The point is, if we look at Node v8 now, it takes the JavaScript source code and transforms it to an intermediate representation, which is only available in memory, then goes on and works on this op3 with an interpreter, exactly like Java does before it got shipped.
But actually, the example that Bogdan made is that, for instance, in the Java platform, you have Scala, Groovy, you have other languages, and all of them output bytecode.
Yes. And this is the standard.
And you create a jar file, and that's what you distribute. And the example of TypeScript and all the other languages that are on the JavaScript platform, they don't generate JavaScript bytecode, they generate JavaScript.
Would you like that better?
No.
Well, it's the difference at
Yes.
this point.
Okay.
The idea is the moment you have bytecode, even if this is called JavaScript now, because this is what JavaScript can be, I can consider JavaScript ES3 bytecode. I get the language out of the picture. And then I can run whatever language I want on it. It's the same story if you want with like machine instructions, you know, I can just compile wherever. It wasn't just a technical itsy-bitsy thing, you know. This is why Python is still stuck in the past. I mean, in 2 versions of language. I'm being very mean to the Python world, but seriously, guys, seriously.
You are.
Anything else? Or we're done. Let's go home.